Section 3.5, Solving Systems in Three Variables. So for this section, we're going to take those concepts we learned in our previous sections and kind of take it up a notch. So before we work with three letters, x and y, we're going to throw in another variable, z. But the way to approach this is by a method you already learned, which is elimination. A linear equation in three variables is an equation equivalent to one of the types ax plus by plus cz equals d. A solution of a system of three equations in three variables is an order triple x, y, z that makes all three equations true. The most efficient method to solve a system of three variables is elimination. Yes, there are other methods. Elimination is probably the easiest one to go about using. Your first step is to eliminate the same variable twice. Solve the following equations. So I have x plus y plus z equals 4, x minus 2y minus z equals 1, and 2x minus y minus 2z equals negative 1. Okay, so your first goal is to get rid of a variable. Which one do you want to eliminate first? There's no right or wrong answer. Looking at these, that z, where I can add to make 0, catches my eye. And from there, I only have to eliminate z once more. So your goal is to eliminate the same variable twice. So let's take equation 1 and equation 2 and equation 3, and working with equations 1 and 2, let's eliminate z. Okay, so I have x plus y plus z and x minus 2y minus z equals 1. We reach our goal of eliminating z. That was a z. And we're left with x plus x is 2x. Y minus 2y is negative y equals 4 plus 1, 5. Okay, this is our first equation. It's super important, but it's not our answer. Okay, next I want to take another two equations and I want to eliminate z again. So I can't use 1 and 2 again, but I can use any other two combinations. So how about 1 and 3? I can multiply equation 1 by 2 so that I can get positive 2, and then I can eliminate those. All right, that's our game plan. So we're going to take equation 1 and equation 3. Equation 1 and 3. You don't have to keep track of your equations. I just need it for me so I know what I'm working with. Okay, so I have equation 1, and we're going to multiply equation 1 by 2, we said, right? So that I have 2x plus 2y plus 2z is equal to 4, and add equation 3. Equation 3 is 2x minus y minus 2z is equal to negative 1. Let's add them, and our z's divide or add to make 0, which is what we wanted. So I have 2x plus 2x is 4x, 2y minus y is plus y, and 4 plus negative 1 is 3. This is our other equation. Okay, for a moment, we're going to forget that we had three variables and only work with those two. So that we have 2x minus y equals 5, and 4x plus y equals 3. So ignore everything you have before and solve that system of linear equations. You can do that. We just did that a couple sections ago. So let's go ahead and solve the system. So let's add these two equations. We see that we can easily eliminate our y's so that we have 2x minus y is equal to 5, 4x plus y equals 3. Our y's add to make 0, and we're left with 6x equals 8. Divide by 6, divide by 6. x is equal to 8 over 6. This fraction can both be divided by 2, so we have 4 over 3. X is equal to 4 over 3. Okay, we have x. Let's find y. Plug in x into one of your equations. Doesn't matter which one. I'll use the second one. Okay, so I have 4x plus y equals 3, and I'm going to plug in x is equal to 4 over 3. Oh, I made a mistake. I was supposed to multiply equation 1 by 2, and I was supposed to make this an 8. That's an 8, and so this right here is an 8, and this right here is an 8. So 5 plus 8, oh well, 8 minus 1, that was a 7. So this right here is a 7. And 5 plus 7 is 12. So this is a 12. There we go. So 12. So we get 2. X is equal to 2. Let's go ahead and plug in x is equal to 2. So that I have 4 times 2 plus y equals 3. 8 plus y equals 3. We subtract 8, y is equal to negative 5. Okay, now that we have our two variables, now I go back to my big picture. And we plug in these two into whichever equation we'd like. I'm going to go ahead and use that first one. So we have x plus y plus z equals 4. And I'm left with y equals 5, y equals negative 5, and x equals 2. So that I have 2 plus y, negative 5, plus z equals 4. All right, 2 plus negative 5 is negative 3, plus z equals 4, plus 3, plus 3, z equals 7. So our answer is always x, y, and z. Our answer is 2, negative 5, and 7. Okay, let's go ahead and go through the next problem. Steps for solving systems of three equations. Write all equations in standard form. Ax plus by plus cz equals d. Write any decimals, clear any decimals or fractions. Choose a variable to eliminate. Then use any two of the three equations to eliminate that variable, getting an equation in two variables. Next, use a different pair of equations to get another equation in the same two variables. Solve the system pair of equations that will give two other numbers. Then use any of the three equations to find the third number. Let's take a look at this problem. So we want to eliminate the same variable twice. These y's catch my eye. Okay, let's eliminate those y's. And I'd like to number my equations, equation 1, 2, and 3. So I'm going to take equations 2 and 3. I add them to eliminate y. So our first goal is eliminate y twice. And it doesn't have to be y, it can be x or z. Y caught my eye because I saw those were an easy one to attack. Okay, so if we eliminate y using equation 2 and 3, I have negative 8x minus y plus z equals negative 5. 2x plus y plus 2z equals 5. I add them and I get negative 6x. My y's are gone. Plus 3z is equal to 0. Okay, now we're going to repeat this process and take two equations and eliminate y again. Okay, so I can eliminate y using equation 1 and equation 3, multiplying equation 3 by 2, so that I can get a 2 here. All right, so equation 1 and equation 3. Notice they're not the same two equations. First I have 2 and 3, now I have 1 and 3. Okay, so for equation 1, we have 4x minus 2y minus 3z is equal to 5. 4x plus 2y plus 2z equals 5. So that's 0, and we're left with 8x plus or minus z is equal to 10. Okay, now let's go ahead and ignore all of our work that we've done so far for a second. And we want to work with two equations that we now have created. So I want to work with only negative 6x plus 3z equals 0. When I made the same mistake again. So this 2 multiplies to each one so that I have 4x, 2y, and that should have been a 4z, and this should be a 10. All right, so that we have 1z, positive 1z, plus z equals 15. Okay, I need to be more careful with my work. I need to show every step. Whenever I say show every step for me, I truly mean it. I always make small mistakes. Okay, let's work with these two equations only. Let's pick a variable to eliminate. I'm thinking, let's multiply this by negative 3 so that I can make my z's cancel. All right, if we do, we're left with negative 6x plus 3z is equal to 0. Okay, I need to show my work. Multiply my negative 3 to each term so that I have negative 3 times 8 is negative 24x. Z times negative 3, negative 3z. And 15 times negative 3, negative 45. All right, so those are gone. And we're left with negative 6 minus 24, negative 30x, and negative 45. Divide by 30 to get x by itself, negative 30. So we're left with x is equal to negative 45 divided by negative 30. Two negatives make a positive, so I have 45 divided by 30. Both of the numbers can be simplified. 15 goes into both of them. 45 divided by 15 is 3, and 30 divided by 15 is 2. So x is equal to 3 over 2. Let's plug it into our function. So I'm going to use that first one. So I have negative 6x plus 3z is equal to 0, and we have that x is equal to 3 over 2. I know we have fractions, but that's okay. Negative 6 times 3 over 2 plus 3z is equal to 0. Okay, what I can think of as over 1. Negative 6 times 3 is negative 18 divided by 2. 18 divided by 2 is negative 9. So I have negative 9 plus 3z is equal to 0, plus 9, plus 9, 3z is equal to 9, divided by 3, divided by 3, z is equal to 3. Okay, so we have x and we have z. Let's go ahead and plug it into our to one of our top equations. All right, I'll move it to the top. So we have that x is equal to 3 over 2, and then we found y is equal to, what did we say, 3? Oh, z is equal to 3. Z is equal to 3. Let's go ahead and plug it into one of these equations. So we have 4x, so 4 times 3 over 2 minus 2y, y is 3. Oh, y is y. We don't have y yet. 2y minus 3z, z is 3, is equal to 5. Okay, well, I can think of this as over 1. And 3 times 4 is 12 divided by 2 minus 2y minus 9 equals 5. 12 divided by 2 is 6. 6 minus 2y minus 9 equals 5. 6 minus 9 is negative 3. Minus 2y equals 5. So I have negative 3 minus 2y, not negative 3. Negative 3y minus 2. Why can't I finish this? All right, negative 3 minus 2y is equal to 5. Add 3 to both sides. We get 8. Negative 2y equals 8. Divided by negative 2, divided by negative 2. We're left with y equals negative 4. So then my answer, x comma y comma z, is 3 over 2, negative 4, and 3. All right. I'll let you do this one on your own. Just keep in mind all of your situations from previous examples, not previous examples, but previous sections of systems apply. So yes, you can always get an answer x comma y comma z. You can also get infinitely many. If you end up with a weird situation where all your variables clear out and you're left with something like 0 equals 0, you know that's infinitely many. You can end up with a situation where you get a false statement, so that means no solution. Where you get something like 3 equals 2, for example. You get a false statement, a number equal to a different number. You know what? Let's do this problem because this problem is different. So example 3. Solve the system. Same idea applies. You want to eliminate the same variable twice. It just depends what variable you want to work with. So I see that this equation, and it doesn't matter, there's no right or wrong answer. I just catch this one doesn't have a y. How about we eliminate y's? So 1 is done. I just have to eliminate y for using equation 1 and 3. Okay, to eliminate y, I would have to multiply my second equation, or my first equation, by a negative 2. Okay, so let's take equation 1 and equation 2. You know, I'm going to write on the side. Let's take equation 1 and multiply it by negative 2. And your goal is to eliminate y twice. Okay, so that we have, let me multiply that 2 to each one so I don't make that same mistake that I keep making. So I have negative 2x minus 2y minus 2z is equal to 180 times 2. That gives us 360. And I'm working with equations 1, and we said 3. And equation 3, we have no x, so we have 0x, but we have a 2y minus z is equal to 0. So we just bring down that 2x. Negative 2x My y's are gone. 2z minus 3z is equal to 360. Okay, so now we have our two equations. We have equation 2, which is x minus z is equal to negative 70. And our new equation, negative 2x minus 3z is equal to 360. So even though in our original problem you saw not every letter was there, that's okay. If it's not there, just write 0 in your variable. Okay, let's ignore our work and only focus on these two. So I want to solve for the variable using only these two. Let me go ahead and multiply my first one by 2 so that I can go ahead and get my x's to cancel. I'll get positive 2 for x. All right, let me show my work so I don't make a silly mistake again. I have 2x minus 2z is equal to negative 140. And negative 2x minus 6z is equal to 360 times 2 equals, I want to say 720. Yes, 720. All right. Okay. I just multiplied my first equation by 2. That second equation did not need any work. So I just have negative 2x minus 3z is equal to 360. Let's go ahead and add. So that's gone. We're left with negative 5z. And negative 140 plus 360, we get 220. All right, we divide by a negative 5. Z is equal to negative 44. Okay, let's go ahead and take a look at number, let's plug it into one of our functions. So let's plug into one of these. And so we're left with, let's use that first one. X minus z equals 70. And we have z is equal to negative 44. So I have x minus negative 44 is equal to 70. I have x plus 44 equals 70. So I have 70 minus 44. That gives us 26. Now we're left to plug both of these into one of our equations. Well, it doesn't matter which one. We're just trying to find y. We can really use any one of them. I'll use that top one. So I have x plus y plus z is equal to 180. Okay, so x is 26, y we don't know, and z is negative 144 equals 180. Okay, so I have negative 144 plus 26. That gives us negative 118 plus y, we get 180. Let's add 118. And we're left with y is equal to 180 plus 118. You get 298. So our values x, y, and z are 26, 298, and negative 144. All right, that's it for this problem and for this section. That was 3.5 solving systems in 3 variables. Thanks.